Hello everyone, this is Pooja and this presentation is a part of Teach 1 for HAP 823 taught by Dr. Alimi. Before going further, let us look at what is propensity scoring. Propensity scoring balances data so that patient characteristics occur at the same rate in treated and untreated groups. Some of the examples include propensity scoring is used to analyze the effect of components of electronic health records on patient care. Or another example could be to compare clinicians' performance. So I will be focusing on question 2 of propensity topic, which reads, the following data provides the survival among cancer patients. The data provides 35 common comorbidities for patients who have or don't have stomach cancer. Use both logistic and ordinary regression to analyze these data and report the difference of findings in particular. Using logistic regression, calculate the propensity to have cancer. Group the diagnosis using SQL. Within the naturally occurring groups of diagnosis, calculate probability of cancer. Calculate the logit of probability. Regress the logit function of the diagnosis using ordinary regression. Report how the coefficients for comorbidities of stomach cancer. How do these coefficients change across the two methods? Next, download the stomach cancer data that is attached to question 2 in the topic and save it as .csv file. This is just a snapshot of how the data looks like. Next, import the data into R using the following R codes. If required, check your working directory and set the working directory as required. Our data consists of about 100K observations and of 38 variables. The next step is to calculate the outcome analysis without propensity scores, meaning making a plain regression model first on the given data. Use the following code to build the model. The code data equals data minus 1 means that it deletes the first column. The first column has something to do with patient IDs or so. It kind of interferes with the calculation of predicted values. And then you define the formula variable with all the columns in our Excel sheet except the outcome variable. I suggest using Notepad++ first to copy paste your variables from the Excel sheet and then copying the same into R. Typing them directly into R kind of gives you errors. Additionally, watch the plus signs and your spaces. Now use the model code to build your model. The model code reads GLM parenthesis formula equals formula, which is the variable you created the variables for the variable formula, and data equals data, and family equals binomial. Once you get the summary of the model, this is the result you get using that code. You see that there are a bunch of predictor variables seen, but let's not conclude yet. Next, let's calculate the fitted values using the R code shown here. As a result of calculating the fitted values, you get this huge list of values. Again, this is just a snapshot of just half of the fitted values. Next, I even plotted the fitted values. Somehow they look way too cluttered to analyze anything. Hence, to further confirm, I did the density of the fitted values towards the right, shown here, and it did not show a good result either. Further, I even did the summary of the fitted values shown at the bottom, which shows the quartile, mean, median, and mode. Next, since the fitted value plots did not show any meaningful result, I had to do the goodness of fit test. The goodness of fit test approximation shows that the propensity score is not being highly predictive. Now I calculated the weights with fitted values using the following R code. This is the result of weights calculated. Again, this is just a snapshot of the weights. Now we need to bind the calculated weights to our variables in order to build the regression model with weights. You use the following R code cbind, which binds the calculated weights to the variables. And the column names displays the entire data after binding the weights. Finally, we build the regression model after adding weights using the following R code. The numbers 2 is the second column from our data, which is the cancer column, and the numbers 3 through 37 is all the comorbidities or the predictors. This is the result of the regression model built after adding weights. Some of the model did not balance out even after adding the weights. All of the variables remain significant predictors. Moving on to the conclusion, like I just mentioned, the model did not balance as the variables remain significant predictors of the treatment. This gives us very limited understanding of the relationship among the variables. And some of the other attributing factors I can think of is that the data set is sometimes large for R to handle. But actually in our case, the data set we have is not very large. Sometimes the nature of the data matters. Logistic regression is probably not very good in terms of making a predictive model with this kind of data. And finally, the overall goodness of fit of propensity score is not being highly predictive of the propensity scores.